Hi, here's our second video, part 2. This one is going to be about the main method, like what is extraction of roots itself, and we'll do that in a minute. But first, I want to go over a little bit of solving by using a graphing calculator. It's a really important thing to be able to do in this class. A couple different methods that you've probably done at least one of these before, but we're going to go over both of them just to compare, and then also compare that with the algebraic method as well. So we're going to first, for part A, is we need to graph y equals 1/2 x squared minus 7, and then we want to try to make y equal to 8. Here's the calculator. So we go to y equals, clear away whatever other junk you have left over. It's going to be y equals, put that 1/2 in parentheses just to make sure the order of operations is done right. Although a lot of the times it doesn't really matter. The parentheses are sometimes unnecessary, but sometimes it's a good idea because it can mess you up sometimes. So anyways, x squared, and then use minus 7 instead of negative 7 here. And then we can graph it. Oh, it looks like we have a weird window, so if it doesn't look quite right, we can go to zoom and go to Z standard is a common one that we'll use a lot. Okay, now it looks like we can have a better picture of it. And we want to see where is approximately the y coordinate equal to 8, and we want to see what x makes that work. So y equals 8 is about right here. We can hit trace to try to get close to that. Okay, so it looks like 5.53 is a little bit too big. 5.3 is a little bit too small. The closest, that's 7.1, that's a lot lower. So the closest we got to here was at about 5.53. Maybe it's a little bit less than that. Let's just say 5.5. And then, so that's one solution. And to get the other solution, we're just going to trace back around to the other side. Trace, trace, trace. Calculator's a little slow. Okay, so, oh, it's about the same symmetrical thing on the other side. So it looks like about negative 5.5 is the other one. And we should point out that these are really not exact. That's what this sort of equals things mean, the wavy equal sign. That means approximately equal to. And if we were to plug in 5.5 or negative 5.5 into this thing to check, we're going to find out we don't get exactly 8. Let's see how that goes. Here I just typed in 1/2 times 5.5 squared minus 7. We want to see if we get 8 from this. So when you hit enter, you get 8.125. It's not exactly 8. So it's not exactly a solution, but it's close to a solution. When you plug in x equals 5.5, you get something close to 8 on the right side, on the left side, but it's not exactly equal to 8. So how can you do that with the intersect feature? That's going to be part B. And the way to do that is we're going to graph the original equation, and we want to see where that intersects the line y equals 8. Y equals 8 is just a line with slope equal to 0 and the y-intercept equal to 8, because you could think of it as, if you want, y equals mx plus b, and it's your m is 0, so you have y equals 0x plus 8. So you can think of it as slope 0 and y-intercept 8, and then we'll see where those intersect. So there I have the two equations plugged in. If you graph it, then you have your parabola and also that horizontal line. That's the line with slope 0 and y equals 8. And to get a precise thing, you do the same thing we did with lines before. To see what is the precise x-coordinate where they meet, you hit second and then calc to get into the calc menu. You can press number 5 to get to the intersect feature. It asks for the two curves. There's only two here, so you can just hit enter twice. The parabola is the first one, the line is the second one. And then it asks for a guess. The guess will help you if you get closer to one of the solutions than the other one. It will it will give you the solution you want. So I'm going to hit enter there. Okay, and it looks like x is 5.477256. And you could do the intersect feature here again to get the other one, but if you believe the graph is symmetrical, you can probably skip that and know that it's going to be x equals negative 5.477226. So those sound like our two solutions. And if you check that, let's see what happens if you plug that into a calculator here to check. Go back to the main screen. Oh, here's a bonus tip. If you hit second entry, whoops, we need to quit first. Sorry, back here. Second entry, I want to overwrite this 5.55. So I'm going to go over there and press the delete button a few times to delete that stuff. And then if I start writing now, I might overwrite the 2. So I'm going to put it in insert mode by hitting second and insert. And we're going to have 5.4772256. Let's check that I copied that right. Yep. And see if we get exactly 8. And we get something really, really close to 8. So that means that wasn't exactly a solution. It must have been, the calculator must have rounded it off a little bit. Just wrote down that checking work I did with the calculator here. So that means these are actually approximate solutions. Even though they're very close to the exact solution, they don't make, when you plug them into x, they don't make 1/2 x squared minus 7 become exactly 8. You just get something really close to 8. So here's a way we can do it exactly. This method is called extraction of roots. And here are the steps I just copied out of the book. So we're going to take our equation from right here. And notice that it is of this form. We have a number times x plus negative 7 equals 8. Oh, it's not quite of that form yet. That's okay. We can still follow the steps. We can start by getting the x squared by itself. Isolate that on one side of the equation. I added 7 to both sides. Now, to get rid of the 1/2, I can multiply both sides by 2, because 2 times 1/2 is 1. And so that just gives you x squared equals 30. And I want to point out here that you should note that there are two solutions at this point, because there's two numbers you could square and get 30. Now, one number you can square and get 30 is just the root of 30 like this, the regular square root of 30. But remember, this always is a positive number. We could see what it is approximately with a calculator if we get the square root button is right here, plug in 30, and that's like the solution we got before. But there's another number you can square and get 30, which is the opposite of that positive square root. So we write it as positive or negative square roots of 30. And anytime you cancel out a square by taking a square root of both sides like this, remember to include that plus or minus. And that goes with along with the two solutions we had before. So now those are exact. If we check it, we should see that it makes the original thing be exactly 8. And we can do that here. We're going to take 1/2 times, let's use the negative square root of 30 as an example. We want to see, does that equal 8? Let's check that it does. So when you square any negative number, it becomes positive, and the square root squared, those cancel out, so we should get 1/2 times just 30 minus 7. 1/2 of 30 is also known as just 15, and we got 15 minus 7 equals 8, and that works. And so that means 15 minus 7 is exactly equal to 8, just like the square root of 30 squared is exactly 30, and that gives you, this is the only way to write this as an exact solution. All right. Thanks for bearing with this video. I know it was a little bit long. In the next one, we'll do a couple applications and practice this extraction of roots some more.